Hi everyone, I am Professor Brian K. Byon, and I received my honorary degree in the class of 2020 PhD by committees from Harvard and Board of Research. Assistant is Jet Schematics, and this course is about operating system. Another word for this course is Shortcut Creation Manual, and it is designed to help you create and perfecting your operating system. And it is recommended that although it's designed for beginners and experts and professionals alike, that you know bases of C++ and C++. And let's begin. So what is operating system? The abbreviation for operating system is OS, and it is used in many technologies. We see that in iOS, we see that in Linux, we see that even in Windows. And we see that in BSD, OS X, and other great places. And those are the adapters, or although they're also called OS itself. How? In order to write an operating system, you will need to at least have a good general knowledge of computer science and operating system design. You'll need to be an expert programmer with at least one low-level programming language, like C++ or C++, like I've mentioned. You'll also need expert debugging skills. Experience with assembly would also help. Here we have a photo here. There's a title operating system, and it's called process management, memory management, file management, secondary storage management, network management, protection system, command interpreter, input-output system management. Now, we all know that if we take out network management system from the operating system assembly not only lacks its predecessors, it cannot use Wi-Fi or internet. So you'll be left out with an operating system or computer that doesn't have any internet. Very interesting, eh? Let's move on, folks. So what else? First, here we have a photo. It says applications, device drivers, guest operating system, and virtualization layer, and hardware resources. And the second, we have applications, device drivers, guest operating system, and virtualization layer, and hardware resources. So, applications are what makes operating systems very interesting, right? We play games through applications. We use softwares, and that's what enhances the hardware resources. All these factors contributes to the hardware resources. It's what's the overall Sentinel programs and the specs that we have in our proud computers. So the entire tool chain you'll be using in order to develop your OS, from compilers, interpreters, debuggers, to emulators, virtualization, software that you could use to test your OS in a virtualized environment. Professionally speaking, emulators is often used in the word gaming in the gaming world, and virtualization is a term used widely in operating system world. So although they're both acts similar, they are sort of quite different factors and terms. So you would want to use virtualization in your vocabulary terms if you are a OS developer, and you would use the word emulators if you are a game developer. And let's move on. More Unix systems and the POSIX standard. POSIX standard just basically quite means it's a portable version of Unix, UNIX. And they are pretty much alike. It really depends on the developers. So here we have a Microsoft Xenix operating system. and this is giving details of this device address, vector, DMA, and comment. So details of the Xenix operating system. That's what this photo is about. I mean, it's a lot like boot menu, but it is not a boot menu. Let's move on. More. The hardware platforms you will be targeting, and I mean right down to the manual for the CPU and its instruction set. You can download manuals for Intel chipsets directly from Intel. This is what I love about Intel, because Intel has a lot of free resources you can check and use, and you can actually download the manuals for Intel chipsets from the Intel website. And it's really neat. It helps a lot for developers, and it's fantastic. So I highly recommend you check out their websites and do download these chipsets. That's up to you. If you like, you know. And here we have a photo. And some of you may be thinking this reminds of a motherboard, right? Because it looks like a motherboard. It's got, you know, it looks like circuits, these lines, and these what looks like metal pieces of a motherboard. That looks like a GPU or CPU planar diagram or some sort. But this is not a GPU or neither of motherboard or circuit. This is actually a magnified photo of a CPU. Right, so this is a photo of a CPU magnified from Google search image. And it behaves like a motherboard, but you could say computer has two CPUs, because it looks like motherboard and CPU. So you can say, or you can say your desktop or a portable laptop has a two motherboards. It runs on two motherboards. People like to say one motherboard, one CPU, but they really look alike. You can just call it two CPU or two motherboards. That is technically correct. Technical terms. And let's move on. More executable formats. This course is designed for professionals, although beginners and, like I said, alike. But I just recommend that you do know basis of OS operating system world. Just as a reminder. Executable formats. So, in order for your OS to be able to load and run binary executable files, you need to know about the various binary executable formats and how they work. So, for example, if you're creating something that was compatible with Unix or Linux, you might want to look at how the ELF executable formats work. So this is a reminder, or for beginners, this is a explanation that Unix will not provide and hold your hand throughout the building your OS. You do need outside resources, and not just internal that's given in Unix or the Linux. And WikiHow or other how-to websites or WikiHow-to websites say that Unix or Linux is like the only thing, and they say, that's going to teach you how to build OS, and you follow their steps, you'll build an OS by just looking at their websites. I know a lot of agencies do that, but no, answer is no. You need outside resources. Let's move on. The few websites and forums out there that are dedicated to OS development, like OSDevNet, Process of Learning, the onus will be entirely on you learn what you need to know. The OS development communities can be quite hostile to new developers too, so be careful not to ask stupid questions or ask information that you could get from a manual. They are often quick to dismiss questions like that with the reply RTFM. So the informations and resources I've gathered in these PowerPoint slides and in this course is very scarce to gather and to find, because a lot of dedications, a lot of work was put into this presentation. And another word, and there's very few companies that is dedicated to entirely OS, because we only have two complete two, um, and I have to mention which monopolies they are, and they um, and there's only two. The reason that for that is the resources are very scarce. It's one of those things people are difficult, very challenging to uh, um, develop and customize. Um, Windows, Apple, only two. They're very scarce. A lot of work was put into this presentation. Build. So there are really three methods in building an operating system. Number one, using pre-existing software components. Number two, writing your own components. Number three, mixing and matching pre-existing software with some of your own custom software. So here we have a photo. It's a Hello World code. It's very popular code. And this gives the slots, and this is the DOS is what gave the Windows or Microsoft OS to actually run the exe files in the earlier days. Without the DOS, the Windows wasn't Windows and Microsoft wasn't Microsoft. DOS was a very important asset in assembly for Windows and Microsoft. So if you really want to build your own custom OS, like powerful as Windows or Microsoft, you really have to check out the pre-existing software components. You have to check out writing your own components, and you have to check out mixing and matching pre-existing software with some of your own custom software. So it is recommended that you do these things. That's entirely up to you. I'm not forcing anybody to do anything. I'm not trying to create any false impressions. That's entirely up to you. Let's try. Existing OS projects. So I've given a very, very interesting resource here. Alternatively, you could perhaps start out by joining an existing OS project, like one of the many Linux distributions, or one of alternative, independent OSCS listed on OSDevNet, if any of them are still alive. So I highly, highly recommend that you check out this website, because it gives you projects from the earlier days to present day on how OS was incited. So you can sort of see how the OS was evolved, sort of like archaeological discoveries, right? You look at the earliest bone fossils, you look at the present day bone fossils, the same linear ancestral heritage. You can look at the bones have evolved, and it teaches you what assets or things were added or wasn't taken out. So I highly recommend you check out this link. And here we have a photo. This is basically a code that gives instructions to your screen. This is not very unlikely for game codes, very unlikely for applications. This is solely for operating system. Without the network assembly, it gives you the so without these codes, your screen wouldn't function. Interface. So after this is part when you have actually finished having a build, you have completed coding, making an operating system. You want to actually move on after finishing your operating system OS. So in terms of packaging, I guess you'd have to install bootable version of your OS onto a hard drive or a USB drive. Then you could take a disk image and that convert it to an ISO file that could be burnt to CD or DVD. So OS is often given hardware products like CD, DVD, USB flash drive, or hard drive. We take out the hard drive here because it usually comes in USB or CD or DVD. So without packaging, you would be just stuck left in OS that's only convertible digitally. I guess it wouldn't be even digital because you can transfer or make products and create a market for your operating system. It is highly recommended that you do these things. Suggestion. For your installation disk, I suppose you would need a bootable system that will boot into a minimal version of your operating system and will then run your installation program that will guide the user through the installation process to install the full OS on their system. So, without the boot menu, you won't be able to download OS. A boot is sort of like an earlier form of OS before OS was even invented. So it is highly, actually, it needs to have a bootable menu. It is to have a bootable system, a minimal version of your operating system before you actually install the operating system media. And here we have a boot system, what it looks like, and here we have the collection and license. So far, we talked about how to create operating system. I taught you how to custom your operating system. I taught you even how to create executable formats. I taught you all these cool methods. That's very scarce, and that's not mentioned in WikiHow or Wiki 2 as of August 11, 2019. And this is after packaging, all these things, and this is the licensing part. A web search for license management software should result in a swathe of companies offering their own solutions, which you'll obviously have to pay to include in your OS. Failing that, you need to work out how to best protect your software yourself. License key management software is mostly proprietary, so the source code and implementation details will be closely guarded, secrets by the companies that own these solutions. So again, you either have to pony up the cash and pay for a license, or create your own solution. So it takes a lot of codes just to build your own license, and like I said again and again, resources are very scarce. So I highly recommend you actually buy their services because license to have a really decent prices and nice deals. When it comes down to licensing, they do want to help you. They do want to help you become a successful Harvard student. So get license, buy license if you can. I recommend that. So license is what gives the key distributions. License is what gives your operating system us up a notch from being hacked. People generating keys. We see that in Windows. You have to purchase keys because it's licensed. You need the keys to install operating system into your boot menu, throughout your boot menu, because the keys are very essential into protecting your market. And after you have completed what's given, so you finished all this packaging, you have product ready, it's being sold on the market, you have this things ready, and it will still have missing features at this stage. You will not have an operating system like Windows, you will not have an operating system like iOS, or even equivalent to those, because regarding your list of missing features, if you want your OS to be able to natively run proprietary executable formats, it will be up to you to create runners for them. And that is because it is missing a runners. And what runners do is creates a distinctive file formats for Windows.exe, iOS to iOS, because Windows cannot run iOS distinctive files, and iOS cannot run distinctive exe executable format files. That's because that's missing runners, and it's entirely up to you to create the runners for them. And I recommend you create unique, distinctive uh, uh, names. You create those names because it's what helps you distinguish people from those unique companies. You wouldn't want to create executable format file for your custom OS just like Windows. You wouldn't want to name it like that. That is because it doesn't make your OS distinctive. It just makes you a copyright. Copyrighted. Let's see. So just by looking at the file and without even looking at what operating system it is, you can tell which operating system it's running. You can just by looking at the file formats, you can tell where the files belong to, and if that's running just by without even looking at the background, you can tell that it's running on Windows. You can tell that it's running on iOS because this is a very unique file that cannot be run by other software. It can be run by certain programs or applications, OS, and runners. So here's basically A, B, C, D. Yeah, so if you want your OS to be able to run Windows executables, you will either have to borrow some code from ACTS as long as your license permits it. This is not ACT you take or SAT. This is one of assembly's lines for a license that I've listed here. And B, use one in your OS. C, write your own runner for that exe, which require you to know everything about the Windows executable format, and you'd have to create or implement your own version of the Windows kernel or API, or use some kind of a translation layer to translate Windows API calls equivalent to API calls used by your OSAS kernel, which is basically what Wine does. They run Windows in a virtualized container. D is the virtualized container I said, compared with the emulator in the game world. Virtualized container is just kind of like an Oracle. And it's essential that you know how to do these methods and these A, B, C, and D. A, B, C, and D. A, B, C, and D. I keep on saying A, B, C, and D. Know all A, B, C, A, D I mentioned. Do all that. I recommend it. That is because you just have to know the creation of OS. You don't know how to do those, then just enjoy these PowerPoints as an LED show. And patch your key distribution. Unless I am misunderstanding what you're talking about here, dealing with license keys and implementation details for you to work out your OS. Know what you're doing. It is a challenging course. It is a challenging topic. Scarce. You will not find these resources I am teaching you here in this lecture. It is a challenging course. Although it looks easy, I'm talking about millions and millions of codes here in this presentation. I'm talking about all these, from basis to the top-notch experts. That's what this course has summed up. So I made it very easy to understand, but this is a really hard concept. It is done through hours and thousands of hours of work. That's what has fruited this presentation from thousands and thousands of hours of work. Literally. It's, because of those great folks who have mentioned here, I'm able to gather and collect what they have shared in these frugality. Yeah, so get the keys, get the patchers, packaging, get the keys, get your license custom OS, product it. I also recommend patenting it. Patent it, yeah. And distro. Distro is a branch of Linux. Once you understand how a Linux distro is put together and how everything works, perhaps you'll have a bit more idea of how to build your OS. So Distro is a combination of codes and combinations because it contains literally millions and millions and millions of codes, if not a lot, for a single person to handle in his lifetime to fully grasp line by line of codes. So try to actually comprehend the distro. Try to actually separate the distro GUI and UI separately and adapt as if it's your own. Once you understand how Linux distro is put together and how everything works, then perhaps you'll have a bit more an idea of how to build your OS. Distro. And thank you all guys for watching. And this is going to have to be in for now for this version. And have fun building your OS. This tutorial and Harvard course beta has taught you how to build your OS. It has taught you how to custom your OS. It has taught beginners have a lot more logic about OS. And you will not find these resources on WikiHow or Wiki. I better not see it there because it's not there. Yeah. Have fun teaching you folks.